Okay, so our next topic is going to be graphing lines. So to graph a line in slope-intercept form, well, to write an equation in slope-intercept form, we have to isolate the y. In other words, we have to solve for y. So in your media notes, here's what we have. We have 3 steps. First step, to graph an equation using slope-intercept form, we have to solve for y. Now notice this is different than what we did before. Before we said graph by the x and y intercepts. But the reason that doesn't always work is if you try to find the x-intercept and you set the y equal to 0, you're going to get a fraction. Okay? And so sometimes that makes things a little bit more complicated. This is a better way of graphing lines. So to graph a line using slope-intercept form, step 1, we solve for y. So let's go ahead and do that. To solve for y, we're going to add 3x to each side. So this will give you 2y equals to 3x minus 4. And then we're going to divide everything by 2. So we'll be given y equals to 3 over 2x minus 4 divided by 2 is 2. Okay, so we get y equals to 3 over 2x minus 2. So we isolated the y. We're done with step 1. Step 2, the slope tells you how to get from point to point, but we need a starting point. Okay, to get a starting point, we plot the y-intercept. So let's think back to the previous video. How do we get the y-intercept? Well, we get the y-intercept by setting the x equal to 0 and solving for y. So if I set the x equal to 0, 3 times 0, that's 0, right? So this will, if I set x equal to 0, this value, whatever it is, will always be 0. So you're left with y equals to negative 2. So this number that is by itself, that is always going to be the y-intercept. And again, I want you to understand why. To get the y-intercept, we're setting the x equal to 0. When you set the x equal to 0, it doesn't matter what this number is. It could be 3/2, it could be negative 10, it could be negative 1 million. 0 times whatever that is going to be 0. So we set the x equal to 0, which eliminates this entire term. So we get y equals to negative 2, or whatever this term is, number is, and that's going to be your y-intercept. Okay, so we start off by plotting the y-intercept. The y-intercept is negative 2. We plot that. Our slope is 3 over 2. Now once we have a point on the line, the slope tells you how to get from one point to the next point. So the slope of 3 over 2, the rise is 3, run is 2. So from here, we can go up 2, or up 3, 1, 2, and 3, since our rise is 3, and then our run is 2. So from there, we're going to go across to 1 and 2, and end up there. So this will be the second point on the line. And we can do that again. We can again go up 3 and over 2. So we can go up 1, 2, 3, and over 2. We can keep doing that forever. And you connect the points, and you will have your line. Remember, going up 3 and over 2, it's the same thing as going down 3, so you can also go down 1, 2, 3 units, and left 2, and you'll still get a point on the line. I would extend it a little bit more. Okay, so step 1, isolate the y. Then you plot the y-intercept. This is the y-intercept because if you set x equal to 0, you get whatever this number is as your y-intercept. And then you use a slope to get more points. Next example, we got 2x minus y equals to positive 3. Okay, so what's your first step? If you're using slope-intercept form to graph, you're going to solve for y. So we subtract 2x from each side. This gives us negative y equals to negative 2x plus 3. But negative y, there's an invisible 1 in the front. So that means we're going to divide everything by negative 1. If we do that, we're going to get y equals to positive 2x minus 3. Okay, so once again, if I were to graph this, I always have to start at a point on the line. And I know for sure that my y-intercept is on the line because that's the definition. So if I set the x equal to 0, this whole thing goes away. I get y equals to negative 3. So my y-intercept is going to be negative 3. My slope is 2 over 1. So from here, I'm going to go up 2 and then I'm going to go across 1. Again, I'm going to go up 2 and across 1. And this will be my line. So start at the y-intercept and then use the point. But what happens if you don't have two variables? Right now we have an x and a y, we have an x and a y. Okay, what happens if you don't have two variables? What if we only have one variable? So your next example, here's what we have. In your next example, we have the following. We want to graph x equals to -3, and we want to graph y equals +5. So what does this tell us? X equals -3 means that the value of x is fixed. It is -3. The y doesn't exist in this equation. So y can be whatever you want it to be, as long as you set x equal to -3. So for example, you could say that x is -3 and y is 0. Doesn't matter what y is? No, as long as x is -3. So x equals -3, the x value is fixed. Another point could be -3, 1. Another point could be -3, 5. It doesn't matter what the y value is, as long as x value is fixed at -3. What does this line look like? Let me just graph the points that I have here. So I have x equals to -3 and y equals to 0. Then I have x equals -3 and y equals 1. Then I have x equals -3 and y equals to 5. If I graph that, it'll give me this vertical line. Now why is the line vertical? Because every single point, regardless of the y value, look, the y value keeps changing. The y value, the vertical values, they keep changing. But what doesn't change? The x value. At each of the points, the x value is going to be -3. So we get a vertical line, and this line is an equation, x equals -3. The next line is y equals 5. Okay, so what about this one? Got my coordinate plane. Y equals 5 means the value of y is fixed. Y is always going to be 5, regardless of what the x is. So it's the exact opposite of this problem. The y value has to be 5. Okay? It doesn't matter what the x is. The x could be -3, the x could be +2, the x could be 0. It doesn't matter. But the y value is fixed at 5. What does this one look like? We have -3, x is -3, y is 5. So 3, 4, 5. So at -3, 5, we have a point. Then at 2, 5, so x is 2, y is 5. At 2, 5, we have a point. At 0, 5, we have a point. So now we're going to get a horizontal line. On the horizontal line, if you look, the x values, they can keep changing. The x can be whatever you want it to be. What doesn't change is the y value. The y value is always going to be set at y equals to +5. Okay, so this line is the line y equals 5. In general, anytime you have x equals to something, you're going to get a vertical line. If you have y equals something, you get a horizontal line if you just have a single variable. Now the next question asks, what is the slope of x equals -3? Alright, so slope is rise over run, right? So let's calculate that. I'm going to take these 2 points. My rise is 1 minus 0, and my run is -3 minus -3. So 1 minus 0 is 1. The two negatives become a positive, so this becomes -3 plus 3. Well, -3 plus 3 is 0. And if you take 1 divided by 0, this is undefined. You can't divide by 0. This is undefined. So any vertical line has an undefined slope. On the other hand, if you take the horizontal line, let's take these 2 points. Our slope is going to be y2 minus y1, which is 5 minus 5, divided by x2 minus x1, which is 2 minus -3. So this gives us 0 over 5, which will be 0. So the slope of any horizontal line is going to be 0. And the slope of any vertical line is going to be undefined.